Hello, this is update 1 of the ECM project. I'd like to talk about this nozzle I made here. This is a brass 0.5mm Mark 8 nozzle for an Ender 3. And what I've done is I've used two nuts here to connect it to a regular heat break that's also standard on an Ender. And this is connected to this Bowden coupling, and it's sealed with a piece of heat shrink tubing inside the heat break. And what this does is I can spray salt water through this and make a fine beam of electrolyte, which I can electrolyze with this wire that's soldered here for a cathode. And my plan was to put this tool head onto my machine and be able to cut using a jet of electrolyte. And this is called jet electrochemical machining. However, this did not work, and I believe the reason that this did not work was because of the voltage I'm using. I'm using 12 volts, where regularly for jet electrochemical machining and capillary electrochemical machining, you use a very high voltage, 400 volts. It's also pulsed sometimes, so you can use pulse width modulation to control cutting. The reason why you need such a high voltage is because of the distance that's being crossed by the ions. The greater the distance between your electrodes, generally the higher the voltage you want. We can get away with 12 volts on the earlier setup because of the low distance between our electrodes, just a few hundred microns. This is a new setup for ECM. I've gotten rid of having the whole pool mounted in between and having to take it on and off whenever you want it to 3D print. Now you can just clip this onto the side of your bed and do electrochemical machining from here. It's much less hassle to set up. And in the spirit of convenience, I've also set up this little D sub connector that you can solder together and place here. And you can just turn your printer off, connect a tool head, turn it back on, and be ready to do electrochemical machining or 3D printing. I've also made a few modifications to the 3D printing tool head. We have a male D-sub connector, and I'm using a 40mm fan instead of 30mm. I'm quite a fan of standardization. I don't like using lots of different types of parts when I could just use one, so I opted to use a 40mm fan. They're more common, they're more useful, so why use 30mm? Well, there is a reason why. This fan provides significantly more airflow than a 30mm fan, so it's very difficult to get a hot end, even with optimized PID settings, up to temperature with a 40mm fan. So what you actually have to do is regulate the voltage. This is a 24 volt fan built for an Ender, and what I've done is set it up to use 7 volts, and that can limit the airflow enough to use on this. So in theory you can do that with 2 resistors, or you can use those buck boost little converter modules that I've put in the GrabCAD description. Those also work very well. So 7 volts on the fan to get this hot end to work. I've also added labels to everything, which is another thing that 3D printing is wonderful for, because it takes very little effort to modify your parts in this sort of way, to give them a custom sort of look. I've also made a modification to the part fan so that it directs airflow more properly. Based on all my testing, I've tested maybe a dozen and a half different designs, and this works very well. I'm able to get remarkable prints with fantastic detail out of this system. So this is a Dante, this is another Dante, and everything prints fantastic. Back to the electrochemical machining tool head. I've made this part right here thicker so that it's more difficult to break, and I have also slightly changed the electrode. So the electrode is still a needle, but I've cut the tip of the needle off so that it exposes a greater cross section. The reason I'm testing this is because I think that the current that we're going to be using, the current that is drawn during the process, is going to be proportional to the surface area of the electrode exposed. And that is going to be a greater factor in this than the actual power supply that we're using. So if we're only drawing 300 milliamps with the tip of the needle, I imagine we'll draw a bit more with a greater cross section, maybe a millimeter diameter. In addition, I've also coated most of the needle except for the tip, just the cross section at the end, with nail polish, and so hopefully that will insulate the needle and keep only the tip as the tool piece. I also wanted to make a note about the placement of these limit switches here. When I was designing this, I put it in the bottom, but after using it, I think that it would be much better if these switches were moved to the top. That way, when you're homing this machine to start a print or to do work, it will naturally home to the maximum position and save time, because regularly when you start a print now, it has to home to the bottom and then travel all the way back up to start prints. So I think it would save time if in the next iteration I were to move the switch to the top position.